and this can be written as sine to the power n minus 2x, and this can be written as 1 minus sine square x. Okay, dx. Can we write down it like this?
Yes, sir.
Yes, sir.
Yes, sir.
And therefore, minus sine to the power n minus 1x cos x plus n minus 1. This can be written as sine to the power n minus 2x dx minus sine to the power nx dx. Can I write down?
Yes, sir.
And this can be written as minus sine n to the power minus 1x cos x plus n minus 1 into sine to the power n minus 2x dx minus n minus 1 I. Can I write down this as I? Because I had considered I is equal to integration of sine to the power nx dx, right?
Yes, sir.
So this is equal to I. Both the sides, the same thing is there. I can bring this on this side. So this will be I1 plus n minus 1 equal to minus sine to the power n minus 1x cos x plus n minus 1 sine to the power n minus 2x dx. Okay. And this is equal to I is equal to minus 1 by n sine to the power n minus 1x cos x plus n minus 1 by n sine to the power n minus 2x. So this is what, if we reduce, we get this particular reduction formula. All right. So we can use this reduction formula for the when n is greater than 0 or greater than 1, you can use it, and this is what it will be. Uh, Now, similarly, we can find out reduction formula for cos to the power n x. Okay, when n is greater than 0 or 1, whatever we write down. Let us say I is equal to cos to the power n minus 1x. So, cos to the power nx. So, I can write down cos n to the power minus 1x cos x dx. Okay, which can be written as cos to the power n minus 1x differentiation of sin x. Can I write down?
Yes, sir.
Okay. So now next, ऊपर वाला लिख लिया? हाँ.
How can we write cos x ds is equal to d sin x?
D sin x is cos x dx. All right.
Yes, I understand.
Yes,
Understood.
sir.
So now this can be written as, once again, integration by parts. So cos to the power n minus 1x sin x minus sin x, and differentiation of this. So differentiation of this will yield n minus 1 cos n minus 2x and into minus uh, sin x dx. Is it okay? Is it okay?
Yes, sir.
Okay.
All right. So cos n to the power minus x, 1x, sin x minus n minus 1, or rather n plus n minus 1, uh, sin a square x cos to the power n minus 2x dx, which can be written as cos n to the power minus 1x sin x plus n minus 1 into 1 minus cos square x cos to the power n minus 2x dx, which can be written as cos n to the power minus 1x sin x plus n minus 1 cos to the power n minus 2x dx minus n minus 1 cos to the power nx dx. Can we write down like this? Just a minute. हेलो हाँ सर बोलिए हाँ क्लास है सर हाँ हाँ देखा मैंने सर हाँ कल चलेगी ठीक है चलिए ठीक 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 This is equal to cos to the power n minus x 1x sin x plus n minus 1 cos to the power n minus 2x dx minus n minus 1 into y. This is equal to y. And so this you can bring out on this side. So I 1 plus n minus 1 is equal to cos to the power n minus 1x sin x plus n minus 1 cos to the power n minus 2x dx, or finally I is equal to 1 by n cos to the power n minus 1x sin x plus n minus 1 by n cos to the power n minus 2x. So this is for the cos to the power n minus x. You can also obtain the same formula by putting x equal to, or x equal to pi by 2 minus y in this formula. Okay, in this formula, if you put and if you differentiate it, it will give you minus dy. Dx will be equal to minus dy. So when you put it in this formula, reduction formula of this, then you will get the same thing. You will get the same thing. Only thing you will have to get y like that. And yx doesn't matter. So you will get the same formula. You can do by yourself. I hope it is clear.
Yes, sir.
Yes, sir.
All right. You can actually alternatively adopt the following methods. Okay, you can adopt these methods also. That first, you can put cos x is equal to t in sine to the power n x dx. when n is odd. When n is odd means मान लो ये 3 है, 5 है, like that if you are it is there, n is equal to 3, 5, 7, like that, then you can put cos x is equal to t. Then this integration will be solved in dt. And then once again you can put back the values of t equal to cos x. So you will get the same formula what we obtained earlier. Okay. Similarly, you can put sin x is equal to t. Okay, in cos to the power nx dx when n is odd. In that case also, you will obtain the formula. But the thing is that n has to be odd. This you need to remember. So using this method also you can solve it. If it is for 3, 5, 7, 9, like that. Okay. Now, if so far you have been doing, if n is small, okay, then you can use this kind of formula. Sin square x is equal to 1 minus cos 2x by 2 kind of formula. Okay, so that using that also you will get answer, but when n is small. When n is small, and it can be put in such kind of trigonometric function formula, then you can get it. And one more important thing which you have to remember, that if you have large n, then you use De Moivre's theorem. And you are aware with the De Moivre's theorem, cos theta plus I sin theta to the power n is equal to cos n theta plus I sin n theta. ये तो पढ़ा होगा आपने?
Yes, sir.
Yes, sir.
Yes, sir.
Right. So here z is equal to cos x plus I sin x. Let us assume it. Then 1 by z will be equal to cos x minus I sin x. Is it or not?
Yes, sir.
Yes, sir.
Right? So then z cos x can be written as z plus 2 cos x, because we have to add it. 2 cos x is equal to z plus 1 by z. Can we write down? इन दोनों को
Yes, sir.
ऐड करेंगे, ये दोनों
Yes,
कट
sir.
जाएगा. This will
Yes, sir.
work,
Yes.
right? And 2i sin x is equal to z minus 1 by z, right?
Yes, sir.
So it means that 2 cos nx can be written as z to the power n plus 1 by z to the power. Can we write down it like this?
Yes, sir.
Okay. And 2i sin x, 2i sin nx can be written as z to the power n minus 1 by z to the power n. That also I can write down.
Yes, sir.
Simple. So 2 cos x to the power n is equal to 2 to the power n cos to the power nx is equal to z plus 1 by z to the power n is equal to z to the power n plus nc1 z n minus 2 plus ncn minus 1 by z to the power n minus 2. Right? Plus final 1 by z. Okay? We can write down it like this.
Yes, sir.
And so I can segregate. So NC1, NC2, you know how to calculate them? Hmm? So z to the power n plus 1 by z to the power n plus nc1 into z to the power n minus 1 plus 1 by n minus 2 plus this and so on and so forth. Okay, so we can write down it like this because this we have already seen. It is nothing but 2 cos nx. Okay, so what it will be? It will be nc1 cos n minus 2x and so on, so forth. Okay, we will get so and so forth. So, so then 2 to the power n cos to the power nx dx is equal to twice of sin nx by n plus nc1 by n minus 2 sin n minus 1 uh, uh, x and so on and so forth. We can write down. And so this is what we can write down. Similarly, one can write down 2i sin x to the power n can be written as y minus 1 by y to the power n, and we can solve. Okay, so likewise if n, but this we can use when n is large. When n is large, we can use this kind of formula also to find out the values. I hope it is clear.
Yes, sir.
All right, so this is what we got. Now I talk about a formula called Wallis formula. Okay. Now suppose I have been given certain limit 0 to pi by 2. So far the limits were not there. If you have might have seen. If suppose you have limit 0 to pi by 2, then sine to the and the integrals under the integral sign, this is what sine to the power n x, it is there, or it could be cos to the power nx dx, but the limit is 0 to pi by 2. Then the Wallis formula says that it can be written as n minus 1 by n minus 3 by n minus 2, n minus 5 by n minus 4, and so on and so forth, 2 by 3 into I1 when n is odd. And it can also be written as n minus 1 by n minus 3 by n minus 2, n minus 5 by n minus 4, and so on and so forth into 1 by 2 IC when n is even. So actually, in case of the limits are imposed on this between 0 to pi by 2, we have this Wallis formula, right? Now, how have you obtained it? Okay, so how have you obtained it? That is what we are going to see. This is for n is even, and when n is odd, this is what we will get. So now let us try to find out, okay?
Sir, what is that? 1 by 2 I?
I0.
Okay, sir.
I0 means when n is equal to 0. This is in na? The subscript में n hai, it means if n is 0, then it is I0. If n is 1, then it is I1. Clear?
Yes, sir.
Now let us see. Just a minute. That's right. नहीं मैं नहीं किसी नहीं दोबारा नहीं देखा सर मैंने वो उसी वक्त आप लोगों को भेजा था मैंने जो करना था कर दिया अच्छा हाँ अच्छा ठीक है सर अच्छा ठीक है ठीक है all right, so this is what we have to prove. Okay, we have to prove this formula. So when n is equal to 0, then I0 is 0 to pi by 2 sine to the power 0x dx. That is 0 to pi by 2 dx. That is integration is x, limit is this, that is equal to pi by 2. Okay, and what is I1? I1 is 0 to pi by 2. This is for the same thing is for cos also. If it is cos 0x cos to the power 0 x dx, then this will also come out to be equal to pi by 2. Okay. So the same thing, whatever we are getting for sine, we will get sine to the power nx. Under the limit 0 to pi by 2, the same we will get for cos to the power nx also. Okay. So that you should remember. Now sine to the power as 1, so sine x dx is equal to minus cos x. The integration of this and cos pi by 2 is 0 minus 0, so that will be 1. Similarly, if it is cos x also, that also will be equal to 1. So simultaneously you can write down that also. Okay? Means this is also true. This is also equal to 1. So we have got the values of I0 and I1, which we had written in that Wallis formula. Okay. Other things we have to find out. Can I remove this?
Yes, sir.
Yes, sir.
Only result I will write down on one side. So I0 is equal to pi by 2 and I1 is equal to 1. Huh? Now In is equal to sine to the power nx dx 0 to pi by 2. This is equal to minus cos x sine to the power n minus 1x by n 0 to pi by 2 plus n minus 1. We know this formula, cos x sine to the power n minus 1x by n. Just now we found out reduction formula for this.
Yes, sir.
Yes, sir. Yes, sir.
Okay, so in that actually I am putting. So n minus 1, 0 to pi by 2 and sine to the power as n minus 2 x dx. This is what we are going to get over here. We are going to get over here sine cos pi by 2 is there. It is multiplying this. So it is 0. And sine 0. Sine 0 is 0. Is it or not? So
Yes, sir.
So this whole thing will become 0. We will get n minus 1 by n, and this n minus n minus 2 means n reduced by 2. यही है ना? Power is reduced by 2. So that is what I am depicting over here. The same चीज को I have depicted like this. Is it okay?
Yes, sir.
So now I find out in minus 2. So what it will be? It should be n minus 3 by n minus 1 in minus 4. Right?
Yes, sir.
If n is reduced by 2, then 2 will be reduced by this is which formula we call it? We call it recurrence method. Recurrence relation. So we see that how the trend is, accordingly the next will also vary like that. इसी तरह से in minus
Sir, in
4.
denominator, n minus 3 by n minus 2 or n minus 1?
Which one?
Sir, in n minus 2 is equal to n minus 3 by n minus 2 or n minus 1 it will be.
Which one? Have I done something?
Third line.
This one. This one.
n minus 3 by n minus 1 or n
So
minus 2?
n की जगह पर n minus 3 का क्या है? n minus 2 होगा. This is what you want to say, na? This will be
Yes,
n
sir.
minus 2. Correct. I just my mistake I wrote. Thank you for correction. I hope now it is clear. In place of
Yes, sir.
n, now we are putting n minus 2. That's all. So if I am putting n minus 4, then this will be n minus 5 by n minus 4 in minus 6,
6.
and so on and so forth. So if I put I3, then what I will get? 2 by 3 I1. Is it or not? Right?
Yes, sir. Yes, sir.
And if I put I2, what it will be? It will be
1 by 2
I0.
I0. Yes, sir.
Okay. So now I have got the recurrence relation because I know I0 and I know I1. So I will put those values over here also. So what I am going to get? I am going to get n minus 1 by n into n minus 3 by n minus 2, n minus 5 by n minus 4, and so on and so forth. 1 by 2 into 5 by 2 when n is even. Okay, and the same thing I will get on the last side. Only the difference will come out in the last. That will be 2 by 3 and n is 1. ठीक है? I1 is 1, so multiplied by 1. If you want to write down, you can write down. Doesn't matter. Multiplied by 1. Okay? 2 by 3 into 1. So this is your Wallis formula. This we have proved. Alright. Now there are certain corollaries to this. यहाँ तक clear है सबको?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Now we talk about some corollaries. So suppose I have some definite integrals. So then some definite integrals can be reduced to Wallis formula. And how can we do it? For example, we have in given 0 to a x to the power n dx by root over a square minus x square. Okay? So then we can bring it that form where we can use this Wallis formula. So we can put x equal to a sin theta. So when we put x equal to a sin theta over here, this will become 0 to pi by 2. The limit will become 0 to pi by 2. Is it or not? When x is 0, a to 0 हो नहीं सकता. So sin x is 0. So that will be 0. And if this is a, then sin x is equal to 1. It means it will be pi by 2. Sin pi by 2 is 1. Is it or not?
Yes, sir.
So this is 1. So in place of this, a to the power n, sin to the power nx, nx, and dx is equal to a cos x. I can write down it like this. So
Yes, sir.
multiplied by a cos x dx. Okay? Right? In fact, I should write down theta here, otherwise it will be confusing. So cos theta d theta. Okay? नहीं तो कंफ्यूजिंग होगा दोनों तरफ dx लिखना. So, just to avoid confusion, I have put some other symbol over here. So I can write down it like this. Divided by root over a square means a 1 minus sin square
Sin
theta
square.
means cos square theta. Can I write down? Cos theta square root. Square root of cos theta. So cos theta and cos theta will cancel out. Okay. This a and a will also cancel out. So this will be a to the power n 0 to pi by 2 sin to the power n theta. Isn't it the same form? Just now we saw. We can, for this we have just proved that Wallis formula. Right?
Yes, sir. Yes, sir.
So
Yes, sir.
we have brought it into. So this kind of integration can be brought into this form, where further we can use Wallis formula. ठीक है? All right?
Yes, sir.
Yes, sir. Yes, sir.
So if n is equal to say 3, you can use Wallis formula. What the answer should be?
Three.
Eh?
Two by three.
You'll have to use the formula for this thing. I mean, odd formula. Okay? Right?
Yes,
sir.
Just use that. There you will get the answer.
2 by 3.
2 by 3 आएगा?
Yes, sir.
Yes, yes, sir.
यही answer. Next is, if you have this kind of integration, dx a square plus x square to the power n. Now apparently it doesn't look similar to Wallis formula, right? But I can convert and bring it that form where I can easily solve it because it has already been solved. So I have to just use the formula. Okay. So here, if I put x is equal to a tan theta, then dx is equal to a sec a square theta d theta. Is it okay? So this will be 0 to pi by 2, and what will be the limit? If it is 0, theta is 0, and if it is infinity, theta is pi by 2. Isn't it? Because tan theta equal to infinity is pi by 2, theta is equal to pi by 2, or tan pi by 2 is equal to infinity. Right?
Yes, sir.
Yes, sir.
Right. So put it over here, a sec square theta d theta by a to the power 2n 1 plus tan square theta to the power n. है? It means 1 plus tan square theta क्या होता है?
Sec a square theta.
Sec square.
तो sec square theta to the power n. Is it okay?
Yes, sir.
So I can write down it as 1 by a to the power 2n minus 1. I can bring it over here, so 2n minus 1. And I can write down 1 by cos square theta. This can be written as 1 by cos square theta, and this can be written as cos square theta to the power n. Can I write down like this?
Yes, sir.
So now once again it has come to the 0 to 2 by 2 cos to the power 2n minus 2 theta. Has it been reduced to the Wallis formula? Because cos to the power n theta is also same. What? Sine to the power n theta d, g between 0 to pi by 2. The formula remains same for both 0 to pi by 2 cos to the power n theta d theta, or 0 to pi by 2 integration sine to the power n theta d theta. Both formula is same. Okay, so one can easily solve it. Once again, we have reduced into the Wallis formula form. Is it okay? Or we can use the form, Wallis formula from this form. Clear?
Yes, sir.
We can take one more. Suppose this kind of integral is there. 0 to infinity dx by a square plus x square to the power n plus 1 by 2. So once again, x is equal to a tan theta, and by using this, I can write down it as a to the power 2n plus 1, 0 to pi by 2, a sec square theta d theta by sec to the power 2n plus 1 theta. Can I write down it like this? Can I write down like this?
Yes, sir.
All right. So just further you have to solve. So what I am going to 1 by a to the power 2n, ठीक है, into 0 to pi by 2 cos to the power 2n minus 2n minus cos to the power 2n plus 1 theta by cos square theta. क्या आएगा? 2n minus 1 theta. Is it okay?
Yes, sir.
So
Yes,
this
sir.
is once again Wallis form. Okay, so Wallis formula form. So once again, then we can use Wallis formula.
सर a पावर 2n plus 1 होगा
कौन सा? ये वाला?
सर नीचे उस
ये वाला? यहाँ a है ना?
यस सर
तो 2n plus 1 आएगा.
ऊपर
क्या
वाले
आएगा?
में
2n plus a power 2n plus 1.
यहाँ पर ऊपर वाला
यस सर.
ये वाला
सर ऊपर, यस सर, फिर नीचे 8 पावर 2n सिर्फ हो गया.
हाँ तो ठीक तो है, गलत है?
यस
सर.
सर, यस सर, यस सर, समझ गया.
हाँ यहाँ तक समझ में आ गया?
Yes, sir.
Yes, sir.
सर,
तो
यस सर.
let us find out reduction formula for 10 to the power nx dx. This is our problem. This is what we need to do. So we can write down it as 10 to the power n minus 2x dx into 10 square x. Can I write down it like this?
Yes, sir.
Okay, so can I write down it like this as well? So 10 to the power n minus 2 x sec square x minus 1 dx. Can I write down it like this? Or I can write down like this, that 10 to the power n minus 2x into sec square x dx minus 10 to the power n minus 2x dx. Can I write down it like this?
Yes, sir.
Or can I write down it like this? 10 to the power n minus 2x d 10x minus 10 to the power n minus 2x dx. Can I write down it like this?
Yes, sir.
Because d 10x is sec square x dx. Huh? This is equal to I, let us say. ठीक है? Now let us try to solve this. And then we will put in this equation 1. So what will we get? UV. UV means 10 to the power n minus 2x into 10x. Is it okay?
Yes, sir.
Minus 10x d du means d 10 to the power minus n minus 2x. Can I write down?
Yes, sir.
Alright, so this is 10 to the power n minus 1x because this is multiplied by 10x, so 10 to the power n minus 1x. Okay, minus 10x. 10x into n minus 2, 10 to the power n minus 3x. हाँ? इसको डिफरेंशिएट करेंगे तो n minus 2, 10 to the power n minus 3x, right? And differentiation of 10x will give us sec square x dx. Is it okay?
Yes, sir.
All right, so 10 to the power n minus 1x minus n minus 2 can be taken out of the integration. This can be written as 10 to the power n minus 2x because this is 10x and this is 10 to the power n minus 3x. So 10 to the power n minus 2x into 1 plus 10 square x dx. Can I write down it like this?
Yes.
Huh?
Yes, sir.
Yes, sir.
Yes, sir.
All right. So this is equal to 10 to the power n minus 1x minus n minus 2, 10 to the power n minus 2x dx minus n minus 2, 10 to the power nx dx. Can I write down? I have
Yes,
just
sir.
multiplied it. And further I can write down it as 10 to the power n minus 1x minus n minus 2, 10 to the power n minus 2x dx minus n minus 2 I. because this is same as the original integration, and so this I can bring on this side. तो छूट गया है क्या इसमें? कुछ छूटा है क्या? I think I have missed something. नहीं, छूटा नहीं. It's okay. All right. So this is what. So हाँ, छूट ये क्या है? I have to put this in equation number 1 because हमने तो इतना ही value निकाला है ना. So this is not equal to I. इसलिए I अब होगा minus 10x to the power 10 to the power n minus 2x. Now it is fine. Okay, this value हमने तो इतना ही value निकाला था ना ये. This value is up to this only. Is it or not?
Yes, sir.
Yes, sir.
So we have put this value. So now this also I have included in equation 1. So now what we are going to get? I am going to get I n minus 2 plus 1 equal to 10 to the power n minus 1 x, and this what will get? N minus 2 plus 1. So it means minus n minus 1 10 to the power n minus 2x. Is it okay?
Yes, sir.
And so I is equal to 1 by n minus 1 10 to the power n minus 1x, and n minus 1 will cancel out. So this is what the integration of 10 to the power nx dx is. All right.
Yes, sir.
All right. So now your problem is that you have to find out integration of sec to the power nx. ठीक है? This is your problem. Show me in the next class. Okay?
Yes,
समझ में आया आज?
Yes, sir.
Yes, sir.
ठीक है. Okay. Stop.
Thank you, sir.
Okay.
Thank you, sir.
Good day, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
गुड मॉर्निंग बोलिए.
Thank you, sir.
कहाँ पर?